Hello everyone. We are going to see today topic grating spectra, means spectrum of light with plane transmission grating. We are knowing that the with help of the grating diffraction pattern is obtained, and in this diffraction pattern the condition of principal maxima due to Young's slit or plane transmission grating is given E plus D sin theta is equal to n lambda, where E plus D is a grating element, theta is angle of diffraction, n is the number of order, and lambda is the wavelength of light in it. Now see carefully here in the diagram to understand the concept of the spectrum analysis. In this diagram, see it is a grating glass. In this grating glass, let us see ray of light. This ray of light is white ray of light. This white ray of light is allowed to fall on grating, and after this a diffraction pattern is obtained here on the screen. Let us see, this is screen where we will see spectrum pattern. Here on the screen. Now see carefully whole of the business here in it. After this, let us see the equation number 1, E plus D sin theta is equal to n lambda, where E plus D is called grating element. Once we have chosen it, E plus D is a constant. And we are knowing this E plus D is given by 2.54 by number of lines marked on grating glass. We know it. N is number of order, angle of diffraction is obtained by the experiment, and lambda is the wavelength of light. Let us see for n is equal to 0. That is called zero order principal maxima. The equation number 1, that is E plus D sin theta, it becomes n is 0, means that is E plus D, grating element cannot be 0. This implies that sin theta is equal to 0, and we may write at this condition theta is equal to 0 degree. So now theta's angle of diffraction is 0 degree. For that, see carefully here in the diagram on the screen, straight here. For all color, we are knowing in white light it is violet to red. The wavelength range is from 4000 angstrom to 8000 angstrom. 4000 for violet and 8000 for red. This is the wavelength range of white light in it. For all colors, for zero order, principal maxima see here. Zero order principal maxima is here. Zero order principal maxima for all 7 color as the same point, combine, and again white fringes appears at the center of it. Now see here in the diagram once more. In the equation number 1, angle of diffraction, sine of angle of diffraction is directly proportional to the wavelength if n is a constant. If we take for first order n is equal to 1, that is called first order principal maxima. Sin theta is directly proportional to lambda, and in white light the wavelength of violet is the least and red is the maximum. So angle of diffraction for violet color is depend on the wavelength of violet, whereas angle of diffraction for red, we are watching for ends color lambda r. So see in the diagram for first order the violet ray color spectrum will be obtained, and violet spectrum and wavelength is red is more. So let us see it is represented by red light. Red color band is formed here, and in between three beautiful color bands are formed. In between that a green is also formed in between. It is the spectrum for n is equal to 1 on both sides. Let us see once more with the violet. Thereafter another green in between. Violet, green, and ultimately the last end color is color band red. Separate three color bands were formed for n is equal to 1. This is called first order principal maxima on either side, in both side of that. Now see for the second order. For second order we will take n is equal to 2. This is called second order principal maxima. For n is equal to 2. The same order, second order, see in the diagram. First for violet color, violet, thereafter green band, and last end red band. Red, green, blue. It is for n is equal to 2, second order principal maxima. And in this side also the same situation occur. Violet spectrum, green spectrum, and then red spectrum. So second order, the number or order obtained according to the number of line available on the grating n. Here see one more thing here in the diagram very carefully. For first order, this is the angle of diffraction for blue in the first order, and it is for the last. It is red, so let us see by red color. This is theta r1, same like as for other order for respective color. So beautiful color spectrum is obtained here in this case. Here in grating spectra, The violet color diffracted least and red color maximum. This is violet color least, red color maximum. See, this is very important, least and max is here, clear, and separated color bands are formed. It is different from the prism spectra where color bands are oppositely, color bands are mixed up, and red is least whereas violet is a maximum. Totally different. Now see one more point. The spectral lines are very sharp and straight, but sharp and straight. This is very important. Intensity of the spectrum is less than the intensity of prism spectra. But the last point here is intensity of color bands obtained on the spectrum pattern on the screen. Their intensity decreases on increasing number of order of spectrum. It means the intensity of second order is less than intensity of first order, same like as intensity of third order is less than second order. See here in this diagram carefully by the grating spectra, bright, central bright, first order spectrum, violet to red, second order spectrum, violet to red. This type beautiful color bands were formed. Now the detail of spectrum you see here once more here in the diagram carefully. Zero order, first order on either side, violet to red, second order, violet to red. So this is whole about grating spectra. I hope you enjoyed well. Thank you and have a nice day to all.